Okay, all right. Notice I've changed the title, Arithmetic Series. Okay. What we were doing before was sequences. A series is when you add all the terms together. So a sequence might have been 1, 2, 3, 4, 5 up to 100. Okay. A series is when you add all the terms together. So what we're now going to look at is when we're summing those terms. Okay, because it's sometimes useful to be able to know what the sum of a particular set of terms actually is. Okay. This is something I've set as a starter. Okay, so work out 1 plus 2 plus 3 up to 100, and I'll give you just 2 minutes to do it. Okay, so if you've got a stopwatch, start timing yourself now, 2 minutes, and then play the video again. Okay. Right. Okay. Why did I give you 2 minutes? Okay, because that's how long Gauss managed to do it. Okay. If you're interested in what Gauss is, what Gauss's problem is all about, just look it up. Okay. I'm not going to do it right now. Okay, maybe in a supplementary video I'll do it. Okay, but not now. Okay. Well, how are you supposed to do it in 2 minutes? Okay, there's got to be a method, and yes, there is a method. Okay, I think the textbook misquotes it. The textbook does state something about Gauss's problem. I don't think they use the same method that he used. I'm going to show you the method that he used in order to do it. Okay. There you go. Well, what Gauss did was he decided to list the numbers in reverse order. Okay. You might think, why do that? Well, let's just see. So in reverse order, it's 100 plus 99 plus 98, all the way down to plus 1. Yeah? So what he then did next, that was interesting, he decided to pair these numbers together and add them. Pair the terms together and add them. So 100 plus 1. What's the next one? 99 plus 2. What's the next one? 98 plus 3. What are all of them going to be? Yeah. They're all going to be 100, aren't they? They're all going to be 101. Did I say 100? Simple time. I went 101. How many 101s are there? Exactly. There's 100, because there are 100 terms, aren't there? So the next thing was to do 100 multiplied by 101. Does that give us our answer, do you think? No. What do we have to do to get our answer? We have to half it. Why do we have to half it? Because what we've done is we've added two lots of the series together. Let me just make it a bit clearer for you. If I call the sum, total sum, S, is that, then this is also S, isn't it? Because it's in reverse order. But then when we add these two together, we've now got this plus this, this plus this, we've got S plus S, 2S. Yeah, you agree? And so 2S will be 100 times 101, so S must be a half of that. Half of 100 times 101. Okay, so 100 times 101, that's going to be 10,100. Half of that is 5,050. Yeah, you hear that? Good. Okay. I'm going to do another one for you. Can you find an expression for that for me, please? Exactly the same method. Exactly the same method. But this time from 1 to n. And when you've done it, what you'll end up with is a formula that will work for any such scenario. I'll talk about it a bit when you've done it. Check it's still recording. Last time it switched off. Hooray. Still recording. Okay. Hopefully you paused it and done it all and everything. Let's just do it in reverse, shall we then? So you've got n plus n minus 1 plus n minus 2, etc. all the way down to plus 1, 3 dots I preferred. And then we add these two lots together, so n plus 1, and then n minus 1 plus 2, which is another n plus 1. So let's write them in brackets so that you can see each term clearly. That plus that is n plus 1. They're all n plus 1s, aren't they? all of them are n plus 1s. Yeah. How many n plus 1s do we have? Exactly. There are n of them, because there's n terms. So n plus 1. And what do we do to find the total sum? Just s on its own? You halve both sides. Half n plus 1. That is a lovely formula. A lovely formula. Why is it a lovely formula? Because it enables us to calculate the sum from 1 to whatever integer you like. Okay, as long as all the terms are integers. Okay, it only works when you put all the integers between 1 and the amount. Then that will allow you to work out the total sum. Okay, so for example, if you wanted to work out the sum from 1 to 10, let's just do that now. So if you do 1 plus 2 plus 3 up to plus 10. That's quite simple because you can probably do it on your own. In fact, why don't you just pause it, or why don't you in your head work out what 1 plus 2 plus 3 plus 4 up to plus 10 actually is, do it the long way around. Okay, pause it. When you've got the answer, just let me know. Okay, unpause it. Well, don't let me know, but you know what I mean. Okay. So n is 10. Okay, so we do half times by 10 times by 10 plus 1, 11. Okay, so 110, half of that, 55. Did you get 55? Well done, well done. If you didn't get 55, oh, what a shame. But hopefully you can see why it's 55. Okay, and you can do it for anything. Okay, let's just do 1 up to 20. Okay, maybe just pause the video and have a go at that. There, clean the board. So we're going to do 1/2 of, this time n is 20, and then 20 plus 1 is 21. Let's work out that. Half times 20 is 10, times 21 is 210. Did you get 210? Whee, we're getting better at this. Nice, okay. That is what we call the sum of the natural numbers, okay. Yes, it is an arithmetic series, okay, but it's actually, if you think about the sum of natural numbers. Sum of natural numbers from 1 to n. I must emphasise, it's got to start at 1, otherwise that formula does not work. Okay. If it doesn't start with 1, you do something else with it, which will come up at some point. Okay, not now. Okay, so as long as it's 1 up to something, then you can do it. It's one of the handy formulas, and it comes in more often than you might actually think. Okay, so natural numbers, of course, means counting numbers 1, 2, 3, 4, 5, 6. And as long as you've got an end value, you can just use that rather neat and handy formula. Okay. Hope you enjoy that. Look up Gauss and the problem. Okay. It's a nice, interesting story. Okay. Maybe had we been in the classroom, I'd have developed it a little bit more. I'd have talked about it. But yeah, I just didn't. Okay, I just didn't. Okay. Anyway, that's that. Are there any questions that you can use this sum for? Okay, straight away I can see exercise 6, question 1. Do you see that? Yeah, you can do that, can't you? Exercise 6, question 1. But then probably you want to use a different formula, a different method for the other ones. Okay, and that's what's coming up in the next video. Okay, because you'll notice in your formula sheets there's another formula for working out the sum of a general arithmetic series, isn't there? Okay, and that's what I aim to cover in the next video. Okay, bye bye.